Okay, so let's start. My name is Orest. I'm Solutions Engineer at StarWind, and I welcome you to our today's webinar. And the topic today is archival and media storage and how it is delivered in ZFS. Now, before we actually jump to discussion, let's take a short look on our today's agenda. So first, we're gonna briefly talk about the archival and media storage overall, about the use cases and peculiarities. Then we're gonna see why actually ZFS for archival and media. And then we're gonna go for a bit more of the details behind the ZFS role in archival storage and in media storage. So basically the short webinar today, and at the end of which we will have our traditional Q&A session, so you can ask me questions on our today's topic and I'll try to answer them. Now let's actually start. So if we are talking about the archival and media storage, there is no need to tell that there is quite a difference between these two use cases. The main purpose of archival storage is, of course, longevity, basically to keep your data for as long as possible. Now, to be fair, there is media designed for archival purposes, and this is LTO. However, it's not always the case, meaning it's not always possible to implement the tape library as part of your infrastructure or as part of your solution. So therefore, we are commonly using spindle drives or simply HDDs. Definitely because of their price and capacities they provide. Now, it's important to understand that HDs on their own are not designed for longevity or for archival purposes. Therefore, we need to look for mechanisms and features that could help us make sure our data remains consistent and accessible in case required during substantial periods of time. Media storage is similar in that it at all more intensive workload. And to be honest, media storage is quite a vast term, and this can include pretty much anything from just storing your MP3 collection that is accessed rarely, and up to streaming for multiple users of various data, or high-resolution video editing by multiple users and editors, or security recording, as for example. Now, depending on the usage, media storage can be accessed more frequently, more sequentially, or more on the random pattern, but the overall, it requires data integrity and availability plus better performance. So why actually ZFS? Well, it would be fair to say that the main benefit and the foremost use case for ZFS, almost as part of any solution, is its data integrity capabilities. And these are, of course, the checksums. Whenever a write occurred, ZFS creates a checksum for the data. And when combined with RAIDZ functionality, where we have redundant parity information, or we have mirror of our data copies, this allows us not just to detect data corruption, but also to repair it. Plus, ZFS is copy on write, which helps us avoiding the write hole during power outage, as it does not modify the blocks in place. And no need to say that ZFS is just more than a file system. It also is the volume manager and provides us with all the RAID capabilities we might need in our solution, eliminating the need to tinker and combine multiple levels of different software or hardware RAID controllers. Plus, of course, it is beneficial for such features as snapshots, compression, and deduplication. Now, so let's take, in fact, a more closer look at the archival storage. So nowadays, to be honest, archival storage is almost always, or at least very frequently, associated with ZFS. And there again is a reason for that I have just mentioned previously. It's just resilient and it's really hard to kill. It provides all the important data integrity mechanisms that are required for archival storage. Again, checksums on writes and copy on write. However, there is the peculiarity behind the archival storage. Now, archival storage is not something you revisit quite often. You basically write to it, but the data might be not accessed at all. Pretty much that's the purpose of the archival storage, just to keep it and keep it available. But in most cases, it's accessed very, very rarely. Now, as we mentioned, ZFS creates checksums on write operations, but it validates those checksums when the data is read. Therefore, this is not the case with the archival storage, since again, we do not read our data frequently. Let's be honest, the archival storage is not just the secondary backup copy. In this case, ZFS on its own by default will not be able to, or might not be able to, repair the data corruption in case it occurred, since it can simply remain there unnoticed as drives degrade. The workaround for this, or the mechanisms to avoid this, is of course scrub. So what scrub does, it basically examines all data in the specified Z pool to verify that the checksums are correct. And in case we have the resilient RAIDZ, for example, mirror or RAIDZ2 or RAIDZ3, ZFS also automatically repairs any damage discovered during the scrub. Now the question resides, how often should we do this? Well, there is a lot of information on that over the web. It's quite a widely discussed topic. In some cases, you'll find the answer that at least once per month, someone will run it once a week. Now, again, the peculiarity of archival storage here. Indeed, it makes sense running scrub, for example, every month, since this is the IO intensive process. And in case you're having the significant workload on your storage, it might hurt a bit. That's why it's of course preferable to scale, to put it on the off times and not run frequently. However, again, this is not the case with archival storage. So for that purpose, it's optimal to run scrub once a week, for example, or at least once per 2 weeks. The better idea would be to automate the entire process, which can be pretty much easily done with cron. We basically need just to set up the email notification, the small script, and add it to the cron tab. And there you go, you will have the fully automated scrub running, for example, once a week or once per 2 weeks. Now, since archival storage, as we mentioned, is not revisited very often, the good idea would be not to rely on the RAIDZ1, which basically is RAID 5. The best case would be not to be pity for the capacity and sacrifice those additional priority information and put your drives in the single RAID Z3 Z pool, or at least RAID Z2. Also, in case of the archival storage, compression might add benefits in terms of the size and in terms of the storage usage. Now, media storage is quite a different beast in this case. Now, again, ZFS fits, of course, perfectly for its data integrity, and this can be said, of course, for any use case with ZFS. The most important here are, of course, checksums and copy on write. Since media storage is written to much more frequently compared to archival, this is extremely important to make sure our media files remain consistent in case the power outage occurs. And that's what ZFS helps with. We also need to take into account that media storage workload can be different and depends on the use case. For example, In streaming, this is mostly sequential workload in high resolution video editing, where we have multiple editors accessing data not from their local copies, but for example, from the shared pool. It can be much more IO intensive and of course random. Now, for this matter, there are a lot of myth and misunderstanding behind ZFS options and how to improve, how to pick the proper layout or what features to use to get the optimal performance. Now, let's get to two most widely, I would say, misunderstood things behind ZFS, namely the S-log and arc and L2 arc. Now, the S-log, which is the special kind of VDEV and is basically the ZIL on the faster storage, it's not write cache as such. In fact, it's just what it is. It's the log device. Moreover, it works only for synchronous writes, which is definitely not the case, or in most cases at least, is not relevant for media workload. I mean, it's not the typical database kind of workload where we get frequent writes and acknowledgements for the write operations. So S-log, in most of the cases, basically dedicating your SSD for an S-log will not result in any meaningful performance impact for most of the media workload type. As to ARC and L2 ARC, now we know that ARC is the RAM cache and L2 ARC is its extension, again on the special VDEV type on the fast SSD storage. Now, the most important thing to understand here, if we are talking about the media storage, is that ARC and L2 ARC are not read-ahead cache. So again, for media storage, most likely it will be useless, both in terms of ARC and L2 ARC. For example, if we are talking about streaming, once a piece of data, for example, video or some music has been streamed, we are not revisiting it. Only if there is a data set that doesn't fit, for example, the ARC size, but fits the L2 ARC SSD, and your users are doing a large amount of random reads on it over and over again, then the L2 ARC might be beneficial. However, it's in fact quite a rare case for media workload, but again, depends on the scale. And if you know your data pattern and the access pattern, you know that you have a large data set that users are frequently revisiting it, then yes, most likely it will not fit the ARC size, which is our RAM, but can fit the L2 ARC and still accelerate the performance for the streaming. In most cases, however, it might not bring any benefits. So what would be the best to achieve performance? Well, the best way, in fact, would be to rely on the proper Z-pool layout. And I'm talking about the VDEVs and basically RAID functionality. Now, for example, if we need more IOPS in case of high resolution video editing with multiple editors, it would be the best case to make a Z-pool not of just a single large VDEV, but of a set of multiple mirrored VDEVs, or alternatively, a set of RAIDZ 1 or RAIDZ 2 VDEVs, since performance in ZFS is added with each new VDEV in Z-pool. The other thing why not to use a huge single VDEV Z-pool is because of the resilvering. The resilvering can take a lot of time, and it's done on the VDEV layer. So it's much more faster and safer to run resilvering when you have multiple smaller VDEVs instead of relying on a single large pool. Plus, the IOPS, of course, will be limited. And to conclude, we also always need to remember that no matter what data integrity mechanism we have, no matter what RAIDZ layout we do, this is not the backup. So backups must always be in place, so keep them at all time. Now, I would like to actually conclude our short webinar today and move to the questions section. So please, in case someone has any questions, just please type them in the questions box. And looks like there are no questions so far. Therefore, I would like to thank everyone for participating and for taking your time to attend this webinar. Hope to see you soon on our next webinar and wish you all the best. Goodbye.